Hey everyone, today we're going to talk about my self-hosted AI stack. It's something that I'm running in my network here at home, and it's something that I recently released a video on. It's a fully local and private AI stack that doesn't reach out to the internet for anything, and I've been using it for some really interesting stuff. So today we're going to walk through my AI stack and hopefully you can spin it up too. We're going to talk about some of the machine requirements as far as hardware and software goes and some of the considerations. Then we'll hop into getting Ollama installed and configured, and then we'll also install and configure open-webui. We'll configure both of those for a few additional services later on that we'll use, and then we'll also install stable diffusion and ComfyUI. We'll also supercharge Home Assistant with AI, giving the assistant access to our Ollama instance, along with giving it voice-to-text and text-to-voice capabilities. And then last but not least, we'll configure VSCode to get some code help from our Ollama instance, basically giving us a co-pilot-like experience for free. We have a lot to cover, and if you haven't realized, this is on a different channel, so if you haven't subscribed to this channel, please do so. It helps out. But I'm not going to rush through this just to appease the algorithm. I'm going to take my time and just let it all unfold. So let's hop in. As far as hardware specs go, this is a server that I've been building over the last couple of months. It's my torn apart HL15. Now, I know a lot of people question whether my ultimate home lab server was a good fit for a home lab, but hopefully this now makes a little bit more sense. So this machine that's torn apart, this HL15, let me go into the stats right here. It's running an older Xeon processor, but that's totally fine because I'm not so much worried about the CPU per se. I use this to get additional lanes so I can add additional hardware inside of this server kind of case. So this is what I refer to as my application server or my AI box. I'll probably just call it my application server. But in here, I have one CPU, 32 logical cores, 256 gigs of RAM, and lots of SSDs inside of here. So pretty typical, right? What makes this atypical is that I also have my NVIDIA GTX 3090, and this is kind of why I stripped this case apart, is because I needed to fit a large 13-inch GPU within this case. And what makes this GPU kind of special or kind of important is a couple of things. So first of all, it has lots of CUDA cores, so this is helpful for processing AI and ML workloads. The boost clock speed, pretty important. So memory type, kind of important, but memory size is pretty important when it comes to AI. When you run AI, you need to load a lot of these models into memory. Now, there are various types of models that you can choose from. There are some smaller models and larger models. For the most part, this 3090 is going to be able to run any of the smaller models, but it is going to have some problems loading the larger models. We'll talk about that. Ollama has some guidance on cards in which compute capability they support, and that all goes back to the CUDA GPUs and what version of CUDA they support. But they don't really go into how much memory because all of this depends, right? I like to think of it like this. So if you're building a gaming rig and you're trying to use a card from 4 or 5 years ago, but trying to play AAA games today, it's not going to work out so well. So kind of think of AI like this. We're getting all of these newer models that also have a lot of memory, that need newer cards for more CUDA cores, higher compute capability, and RAM, as I mentioned before. So it's one thing to kind of test this out and see how it works on an older card. It might be slow, but it's another thing to kind of play with this and integrate it into some of your home lab, which requires, I'd say, a medium-sized card. And it's another thing to train models, which will take multiple high-end consumer-grade video cards or some enterprise cards, but I kind of think that those are out of the question unless you're running older enterprise cards. All of that being said, I think that if you have any 30 series card, maybe 60, 70, 80, 90, and the same with 40 series cards, you'll be able to do everything that we're going to do today. You might be able to get by with something lower, something different. I don't have those cards to test it, but everything we're going to do today is going to use small models. So as long as you have around 8 gigs of VRAM, you should be good. But then again, you're going to need modern compute capabilities and a lot of CUDA cores. So now do you understand why I said it depends? Also, I haven't tested this with AMD or Intel. You're free to try it, but you'll find if you have an NVIDIA video card, it's going to work a lot better because there's more support for it, because they're a lot better at doing these kinds of things. at least for now. So going back to my hardware, I actually installed Proxmox on that Storinator. It's actually the Storinator, not the HL15. And I did that so I can create a virtual machine and then assign resources to that. Now you might be asking, why didn't I go bare metal? Well, I like Proxmox, and using Proxmox makes it really easy to back up these virtual machines, as well as move them around if I need to, give it more resources, take away resources. And if I went bare metal and assigned all of this hardware to this machine, I wouldn't be fully utilizing all that hardware. So for that reason, I usually pick Proxmox. Even if I have a VM of 1, I usually pick Proxmox because backups are super easy that way. So anyways, looking at this virtual machine, you can see that I've assigned it all 32 CPUs. It was fine with 16. I was testing some stuff out to see if I could get better performance, but I didn't. So 16 cores would be fine. 8 was actually fine too when I tested, but 8 is kind of getting into the lower end of what you want. And as far as RAM goes, I've loaded this up to 96. I had 32 gigs of RAM on here. It was totally fine. And, Linux will always use as much RAM as you can give it. Now, that might seem counterintuitive if you install a bunch of RAM and it immediately gets used, but you want all of your RAM to be used because things are cached then in memory and things will just run faster. Now, this is running on SSDs, and I've had to change this a few times. So at first I started out with around 100 gig SSD, totally fine, quickly went to 150, quickly went to 200, 300, 400, and now I'm at 500 gigs. But you'll quickly find that you're gonna need lots of space for all of these models as well as these images that we're going to use. But I mean, 500 gigs, it's not really that much considering hard drives are so huge right now. And then all of the rest outside of this NVIDIA card right here that I've added, this raw device of NVIDIA, scroll down here, we should see it in the list. Right here is my GTX 3090, and then I pass that through to the machine. So cool, so we have our machine built. The next thing you'll need to do is consider an operating system. As far as the operating system goes, I always choose Ubuntu Server. It's just what I run, but I'm running Ubuntu Server 2404 and it's running just fine. So the latest LTS. You'll usually be fine if you're running the latest LTS version as long as it's not like day 0 of the LTS. But that's what I installed on this server and it's running great. The next thing I did was install the NVIDIA drivers on Ubuntu. You can find this on Ubuntu's website. I'll also have all of these commands and everything in my documentation site. But if you're following along, this is what you'll want to run. Now I know this differentiates between a desktop and a server. I followed the desktop instructions and it worked just fine. I followed the server ones later and it didn't work. I built this a few times. But I ran this Ubuntu drivers list. I listed them all. And then I just installed the latest suggested one that they do if you run this command here, which is just Ubuntu's -driver install. That will install the latest one for desktop. That will totally work fine. Didn't install the server one. I didn't install Fabric because I'm not using it. And then you'll have to reboot and you should be totally fine. As soon as you get the drivers installed, I would actually try an NVIDIA SMI, which will load a utility so that you can see the specs of your card, and that will tell you that the drivers are working. If you don't have NVIDIA SMI, which I think you should from the last command, you'll need to install it with NVIDIA-utils and then the version of your driver. And then that should give it to you. The next thing you'll need to install is the NVIDIA Container Toolkit, which will allow your containers to connect to that driver. And I think this has all of the CUDA stuff so that you don't have to install it. Yes, we're going with Docker, and I do that for many, many reasons. The biggest reason is that I want to use images that already have everything installed, and I don't want to worry about dependencies. I couldn't imagine doing this without Docker because of all the dependencies you have to worry about, especially all of the Python dependencies, Python versions. And so that's all solved with Docker. And of course I'm going to use Docker. It's me. So anyways, you'll need to install the NVIDIA Container Toolkit. Oh, and note we didn't install Docker yet. If you have it installed, that's totally fine, but you'll need to do one more command here. But what you'll want to do is run all of these commands. You'll want to follow the apt version of the installation. So it's add the repositories, edit the list, update the repositories, install the Container Toolkit, and then you'll have to scroll all the way down here. And then you'll need to configure Docker to actually use this NVIDIA Container Toolkit with this command. And then if you have Docker installed, you'll need to just restart the Docker daemon. So if you don't have Docker installed, you don't need to do that yet. If you don't have the Docker engine installed, now's a great time to do it. It's pretty easy. I'll have some documentation on this too, but you just want to install the Docker engine and not the Docker desktop. Again, I'll have all of those commands on my website. So once Docker installed, now let's test to see that NVIDIA SMI can run inside of a container. So here's the command to run. It's going to run a Docker container. It's going to set the runtime to NVIDIA. It's going to give it access to all GPUs, and then it's going to run NVIDIA SMI. So let's run this really quick. It's going to pull the Ubuntu image that we said it's from, download it, and it ran. And here's the output. So this is looking pretty good. This means Docker now has access to NVIDIA. So now we just need to create our stacks. So what I did was put all of my stacks into cd opt stacks. Here you can see some of my stacks. One's an AI stack, home assistant stack, homepage, Plex, Portainer, scripted, tout delete traffic. But the one we're going to focus on today, at least for now, is the AI stack. So I created a folder called AI stack, and that's just a mkdir. And then if we look inside of this folder, we're going to see lots of stuff going on in here. So you can see my compose file, an Ollama folder, an open-webui folder, a searXNG or a searXNG or a searching, I think that's really the name, folder, stable diffusion web UI Docker, that's a long name folder, and then a whisper folder. So I created all of these folders so that in my compose stack, I can spin up all of these containers. Let me show you what I mean. Here's my AI stack folder. You can see it has a couple of services, just highlight them right now. So we have the Ollama service with a lot going on, open-webui with a lot going on, more configuration. This searching, that's what I'm going to call it for now, a little bit of configuration. Then we have stable diffusion web UI. This is really ComfyUI. I'll talk about that a little bit later, but it's going to be the UI that we're going to access stable diffusion models with. Then I have the Whisper kind of stack going on inside of here. Not really a stack within a stack, but these are the services that I need to support the Whisper web UI. So I have Mongo, a database engine, a translate service, the Whisper container itself, which is a combination of services you'll see later on. But this is the Whisper web UI. It's probably a better way to put it. And that's it, and networks. So if we look down here, we can see networks. I've called this network Traefik and set it external to true. Now this network can be called anything you want it to. It could be called external, which would be weird, but it could be called external network or proxy, whatever you want it to be. I've named it Traefik because that's the one entry point you'll see that I've exposed. Now, if you don't want to use Traefik, that's totally fine. I think you can just comment out the Traefik labels that I have and it should work just fine. But I use it because I want a single entry point for anyone coming into the stack, and that's going to be Traefik, my reverse proxy with certificates. I think this will make more sense as we walk through this, so let's just dive into one of these. So first, Ollama. Now, Ollama, pretty easy. Ollama image. I've named the container name Ollama. I'm saying, hey, always restart unless I stop it myself. Then I'm setting some environment variables. So I'm saying, hey, your PUID is whoever the PUID is that you pass in, or just default to 1000. So this is a way to specify a default, this colon dash. And so I've said that for both PGID and PUID. If you need to know what your PUID and your PGID is, it's most likely going to be 1000. But you can check by typing in ID and you should see it there. And you can see mine is 1000. Now, I've also created ways to override this in an environment variable. You can see here, it's not much here. There are some kind of secrets here, but I'll change all of these. So if you want to override the PGID and the PUID that all of these use, you could use it in a .env right here. So that's kind of my way to say, hey, just use 1000. It's what mine typically is. If I need to override it, I'll do it in an environment variable so I'm not hard coding that in the compose stack itself. So the next flag I have here is Ollama keep alive, and I set it to 24 hours. This is a flag to tell Ollama to keep the models loaded for 24 hours. You know, obviously unless it needs the memory. But this is super helpful because Ollama, I think by default, will unload the models after 5 minutes, which is super painful because if you wait 10 minutes to use it, it's going to load that model again. It's going to add, 30, 40, 50 seconds each time you make a command. So I basically said, hey, Ollama, keep it in memory for 24 hours. I actually might tune that down a little bit more. 24 hours is pretty long. I do want to compare to see if it's using a lot of energy to keep this in memory. And so I might trim it down to 1 hour or something like that. Enable image generation. This is going to be used a little bit later on. This will integrate Stable Diffusion into chat, as you saw in that video, so that we can generate images from chat. Next is ComfyUI base URL, and this is telling Ollama what the URL is to get to our Stable Diffusion web UI, which is basically Comfy. And it's using it by internal name right here. So Stable Diffusion web UI. And so instead of using, a port and IP or local host, I'm saying get it from this host name called Stable Diffusion web UI. And within this stack, that's the name of Comfy. So how did I get that? We scroll down here, we can see that we have Stable Diffusion web UI. So I'm pointing it at this container or this service within the stack. So pretty cool. I don't need to expose stuff. And the port is 7860, and that's Comfy's port, which makes this a little bit challenging because, you don't know the port. If you don't expose all the ports, you don't know the ports. So if you want to expose the ports, totally fine. I don't. I like to do it this way so that nothing can access these services without going through Traefik. And then I can put some authentication on it, which you'll see here in a little bit. A lot of these services are going to have a lot of the same properties, so I'll go through this really quick. It can connect to a network called Traefik. There are volumes to map, so I'm mapping to the time zone and local time. I'm also mapping to a folder within here called Ollama to the containers root of Ollama. Then I'm setting a lot of labels. And so if you are familiar with Traefik, you'll know what to do here. If you're not familiar with Traefik and don't want to use it, you could just comment this totally out. So you might see this here. I actually did create a user in basic auth for this endpoint. So this means anyone outside of the stack needs to supply basic credentials to actually get to the service. Otherwise, they'll get a 401. Anyone internally doesn't need to supply it. So this is kind of, not the best practice, but Ollama does not have a great way or a way in general to give me API tokens, which is what I really need for some of my other services. I want to be able to supply a token to get to these services, but Ollama doesn't support it yet, maybe never. So what I did was create a basic auth middleware that says, hey, anyone coming in through Traefik has to supply basic auth credentials. And if they don't, they're not getting in. Anyone internally can still access it. But pretty cool. I figured that out, and I'll show you where it's used later on. And then this is the new way to basically say, hey, use a GPU. Use the GPU for NVIDIA. And that's the new way to do it in Compose with Docker. Cool. That was a lot about Ollama. That's kind of the foundation for a lot of this stuff. But let's talk about open-webui so we could spin these both up and actually see something on the screen other than a CLI and my IDE. So open-webui, as you saw, was the UI that I used in that video to chat with Ollama and manage a lot of my models. So I'm using open-webui latest, naming that container open-webui, same kind of deal. We'll see, use the Traefik called network. We're going to use, the PUID kind of convention that I have that I talked about earlier. We're setting the Ollama base URL. And again, we're using internal networking, internal Docker networking. So we're saying, hey, how do I access Ollama? Well, it's over Docker networking on HTTP Ollama and then Ollama's port. And again, this maps back to this service right here. That's how I know the service name. Then we're enabling a lot of stuff for searchng or searching. So these are some defaults for configuring searchng within open-webui. These are a lot of the defaults they said to set. You can override these in the UI later, but I like to set them here so they're just set and I don't need to figure that out. But how many results, which search engine to use, how many concurrent requests will go out, and then the query URL, which is kind of important. They say to use this. I found it works without this query param. It's kind of weird. But since they say in their docs to use this query param of this, that's what I'm going to use. But it will actually work without this too, I found. So this is how we configure searchng. We'll talk about the container here in a second. But a lot of this is the same. Map a time zone, map a local time, map some folders, enable Traefik again. And how are we going to get to this? Well, through a DNS entry called chat.local.tektron.us. This is an internal domain that I use, and I'm using Traefik to get certificates for it here internally. And I'm saying, hey, it does depend on Ollama. Open-webui can't run without Ollama, so we may as well wait until it starts up. And then extra host, this is configuration they say to add. So I think this is adding a host entry on that container, but this will help route traffic to this container. I found that I need it, and they say you need it. So real quick, since we are talking about searchng, that search engine, we may as well talk about the container to create it. And this is it, searchng. Again, if we see the name, we're saying, hey, the service name is searchng for this query URL. That's how we got it there. Here's the image we're using. Here's the container name, so I'm naming it that. I kind of do that with a lot of them, even though most of them are totally fine in a compose stack. Saying to use the network of traffic. And then again, my convention for PUID, PGID. Then setting volumes again, local time, time zone, and then a local folder for searchng, which it needs to write some of this data. Depends on. So hey, this guy depends on Ollama as well as open-webui. Now, it could run without open-webui, but open-webui web search won't work without it. So I say, hey, it depends on that in order to run. Cool. So I'm saying that this is kind of our Ollama chat stack. And so let's spin this up really quick so we can see that. So the command that I'm going to use from the root of AI stack is docker compose up-d build force recreate remove orphans. This does a lot of things that you'll see kind of later on, but it's telling docker compose, hey, spin up the stack, build any containers that you need to. So if any of these services in that stack have a build key, build them. Force to recreate all of those images. And then, hey, if we have orphans that were assigned to the previous stack, just get rid of those too. So let's run that. You can see it's doing a few extra things. We'll talk about those as we talk about other items in the stack. But really, we want to see Ollama come up. We want to see open-webui come up. And we want to see searching come up. And it did. Now that we have our chat stack up, we can play around and manage the models. So if you're wondering how I access this stack really quick, again, just a reminder, I defined it in Traefik, which is right here. So I went to chat.local.tektronic.us. So I'm going to go to that in my URL. And if you're using Traefik, that DNS entry should actually, well, it should be a CNAME, either way, but that should actually point to your Docker machine that you're running. So for me, what does that mean? Well, my Docker machine right here that's running everything, if we look at the summary right here, we can see that my IP address is 192.168.0.200. So chat.local.tektronic.us points to this IP address because that's where Traefik running. Then once Traefik gets the request, it routes it internally to that stack. So anyway, sorry if that's review. I just kind of want to be clear while we have the time to do so. So anyways, chat should work pretty good after you get some models. So how do you get some models? Well, we want to go into settings, and then we want to go into admin settings. This throws me off every time. So we're in admin settings, and then we want to go to models. And you can see here, I have a lot of different models. These are pretty common models, I guess, or popular models from pretty reputable sources. But if I wanted to delete some, I could. But so how did I download them? I downloaded using this form field right here, which downloads them from ollama.com. So if we go out to ollama.com, we'll see some pretty popular models that are hosted here. We can see Gemma 2, Llama 3, Qwen 2, DeepSeek Coder, Phi 3, all the ones I talked about during that video. I think a good model to start out with is Llama 3. And so this is from Meta. It's been pre-trained. And so you'll notice they have an 8B and a 70B version of these models. Now, one is, I think, 8 billion parameters, and the other is 70 billion parameters. I think that's what it stands for. And obviously, the more parameters you have, the bigger the model's going to be. Why is that important? Well, depending on the RAM of your video card, you may not be able to run some of these larger models, like the 70B model. That won't fit inside of my 3090 by itself, so I have to use the 8B model. But anyways, looking at this, you can use the 70B model if you want, but you can see you need 40 gigs of memory. My card doesn't have 40 gigs of memory. I think it has 24 gigs of memory. So I'm going to have to use the 8B version. Now, you could get multiple cards. I think what they're saying right now, the best value is getting two 3090s and combining them together. And that would give you, I don't know, 44 gigs of memory where you could load this. But I'm not going to do this. 8B is super smart and super fine for me. And there are lots of other models you could try and use, but I think this is a good place to start. So what you want to do is basically copy this right here. So we're saying, hey, get the Llama model and get the 8B version. So we can copy that right here. And let's go back to open-webui. And then here you would paste that model. Now I already have it, so I'm not going to download it again. But here you would paste that model. And this is going to be a big model. As you can see, it's going to be 4.3 gigs. And this is what I was talking about earlier. You're going to need a lot of disk space, but same goes for a gaming machine. Treat these like Steam games. Some of them are going to be 17 gigs. Some of them might be 2 gigs. So again, I always try to look at this like, you know, you're building a high-end rig. It has a different purpose and a different workload, but a lot of the same kind of components, you know, that you would tune for differently or optimize for differently. Anyways, I know it's not a one-to-one comparison, but it helps me kind of frame up the conversation whenever people say, hey, what kind of machine do I need? Anyways, so after you download that, you should have that model. And then when you go into chat, so if you want to switch models, you would do it here. So here's the Llama 3B right here. That's the default. I like to keep it on. And I can ask it a question. Please list all US states and capitals. You can see here there's a little bit of a stutter. So what's going on right then and there? It was actually loading that up within memory. So you saw that stutter, that was in real time. Now let's ask it something else. Please list all of the states in the US. Different question. Now that was near instantaneous. And that's because that model is now in memory. Let's take a look behind the scenes what's going on. So I'm in this machine. I'm going to run a BTOP because that's a good visualization. I could actually run NVTOP. That's probably a better visualization, but I want you to kind of see what's going on with CPU and GPU. So if we look right now, we can see that, hey, 6 gigs of memory is being used. This probably has to do with some of the other small models that I'm using. But typically after loading that small model, you're using about 4 gigs. So let's run a command and then we'll tab back to here. How to use Kubernetes. Good one. And as you could see, it was starting to list it, and we can see the GPU is kind of getting a hit right here. So as it's typing out that response, it's actually using the GPU. We didn't use any additional memory, you can see here, and you can see the spike now quit. So it was using the GPU as it was predicting all of this text to type next. And as you can see, it's ramped back down, still in memory, and it's still running pretty okay. Actually, let's actually test my memory theory with power. So if I run an NVIDIA SMI, that's only using 7 watts of power right now, which is pretty awesome and interesting to me because I thought for sure that having a 3090 in your system just being there was going to use more than 7 or 8 watts of power. But as you can see, it's only using 7 watts. Now, I say only 7 watts, like that's like a Raspberry Pi on full tilt probably. But when you think of how big that card is and how much it can consume, up to 350 watts, 7 watts at idle for that card, I think is pretty okay. Would I love 0? Sure, but I don't think that's possible. So let's keep our BTOP in. And now let's do what I was talking about earlier. Let's switch our model to a different model. So let's switch to that Phi 3 by Microsoft. And let's ask the same question. Please explain Kubernetes. You can see it's pausing. Let's go to BTOP. So right now, so it did dump some of that memory and it's loaded the new model in. And right now it's probably giving us back a response. And it's actually going a little bit slow because this Microsoft model has been saying a lot. I don't know what's up with this model. I've never really used it before, but it's like going on forever. It's like writing a book about Kubernetes right now. I guess I should have looked to see what the model was doing. But it finally stopped now, and I have no idea what it said because I think it even overloaded the buffer within the browser. So anyways, that was not a good example. Let me start a new chat and start a new model. So I'm just going to ask this code Gemma, which is about the same size. So write a hello world and go. We can see it's waiting. Go back to here. This is what I wanted to see. We should start to see the memory going up, and it's loaded. So it's now the model is in memory, took 7.5 gigs, and the response was really quick to spit out that response and predict all that text. And we can see this is where it spit out the text, which, oh, would help if I spelled that correctly. I don't know if that was autocorrect. Probably autocorrect. I'm going to blame autocorrect, right? A hello world in Go. Now again, the model, well, it was terrible. But the model was already loaded, and you can see it spit that out right away. We go back to the GPU. I mean, barely a blip there. But this isn't a great model for conversation. It's more of a code completion one. So a little bit trained, but not trained on the right thing. Anyways, now I'll show you the 70B, which is 40 gigs. And I'm only doing this to illustrate what might be happening to some people if, one, they don't have enough RAM in their video card to support even 8 gigs, or 2, they have older CUDA or something like that. So what I'm going to say is explain Kubernetes, and we'll see what happens on the 70B, which remember was a 40 gig model. So first, if we go back to here and we look at the GPU, it's going to start loading this up with memory, but then it will quickly run out of memory, and it's still loading the memory. You can see Ollama is using 22 gigs, 23 gigs, 24 gigs, and this is RAM. It's going up, it's loading up, 30 gigs, 31 gigs. And now it's using all of the RAM, all of the VRAM, along with 38 gigs of my system RAM. And now it's pegging the GPU to predict some of that text. And it's pegging at least one core of the CPU, probably more. So let's see what that looks like. This is what the experience looks like. And so if you're using older cards or cards that don't have enough memory or older versions of CUDA or large models, you'll get this type of experience, which for me, running a 3090 doesn't sit well. Spent all this money on a card, and this is what you get. But again, these workloads require lots of RAM, modern CUDA, which I'm assuming we're going to see lots more of in cards coming in the future. So anyways, let's stop that. Before I forget, let's change our model back, and then I'm just gonna do this test just so I load that model back into RAM, so the next prompt I don't have to wait. And again, like I was talking about earlier, now that this model is loaded, as long as memory isn't needed, Ollama is gonna keep this model loaded in memory for up to 24 hours, and then it will purge it. So anyways, a couple other things. We talked about searchng. Let's go into our settings. Let's go into admin settings. Go into web search. So this should be toggled on now. So it should have been enabled because we did that in Docker. We set the default search engine. Here's where we set that query right here. And that's why I was saying I don't really think you need that query param, because it turns out like this. Anyways, the search count results and concurrent requests, that should all be pretty good. So if we go to a new chat, we turn on web search, and we'll do the same search we did in that video, which was things to do in Minneapolis. And you'll see it's actually firing up that search engine, or it's making those requests through that search engine. This can take some time, but it's usually pretty quick. Here it goes. It searched 3 sites, and then it summarized them for us. So it did it from Minneapolis.org and from TripAdvisor. Says 3 sites. I don't know where the third one is. Oh, right there. And then also travelusnews.com. So pretty cool. Pretty cool. I didn't know that that was right there. And so now this is giving us anonymous searches. So if we want to do current weather in Minneapolis, we could, and we can get the current conditions. So weather.com, AccuWeather. It's the same sources. Yeah. Oh, weather forecast and weather current. So 80. Yeah, it is. And feels like 84. It is pretty warm and pretty humid. Next up on our list is Stable Diffusion. Really ComfyUI to use the Stable Diffusion models. This one's a little bit different because I actually had to do things a little bit different, because this one is actually kind of hard or was hard to get working. Let me show you what I mean. So the container that I use is this ADB Barho Stable Diffusion Web UI Docker, which is pretty cool. And it actually gives you a few UIs to choose from. And so when you start this, you can actually choose between any of these UIs. Once I started using it, I thought, well, I'm just going to use ComfyUI once I learned how to use it. But then there were a few challenges with that. But there is a problem with this GitHub repo, and I should probably open an issue or a pull request to fix it. We'll talk about it. So since I decided I'm going to use ComfyUI, I didn't have to do a lot of this stuff where I was passing in a profile, and based on that profile, loading one of these UIs. Now, you're absolutely welcome to do that. If you want to use this instead of what I'm doing, go for it. Absolutely do it. It's mostly the same, but this will give you an easy way to check out all of these UIs. Anyways, I standardize on ComfyUI, and I'll show you how I did that. So I created this folder called Stable Diffusion Web UI Docker. In here, you can see it. Hey, it's saying master branch. That's because I actually git cloned that repo inside of here. Well, actually one level up, but I cloned that repo that we just saw. And that was really to get a few things, mostly the folders and a folder structure and a few other things. But I did clone that repo to get it. Now, I did do a few things different. If I do a git status, it should show me what I changed. Yeah, I changed something. So if I go into, actually, if I do a git diff, we should be able to see what I changed. Yeah, so this is the one thing that I changed. And this was actually hard to track down. So when he's building this container, he's doing a git checkout master. So it's pulling down master. And then he's doing a git reset hard to this commit SHA. So there must be some commit SHA, which he assumes works well, and sticking with that, well, I found it doesn't work well, and I pinpointed it to this. So I'm basically saying, hey, just give me the latest when we build. Probably not the best thing to do. I should probably pin this to the current commit SHA so that I know it will continue to work. Feel free to do that. I might even update that in my documentation before you see this. But then again, at some point that won't work. So anyway, so that's all I did. And so let's actually, let's look at that Docker file so you can see. I will have this Docker file too in my documentation, but you can see right here, what I did was comment out his reset hard and just say, hey, git master, and then do all of the rest of this stuff. So let's go back up to here. So let's go back up to our stack, and I'll show you now in our stack in YAML. So we can see I have this stable diffusion download. This is needed for stable diffusion web UI, really ComfyUI to run. I think this allows you to download the files from the service, but the first line you can see is a build command. So this is actually going to build that Docker file that we just saw. So way deep down in this repo, in services/download, there's a Docker file in there, and we're going to build that. And then when it runs, I'm going to name it Comfy Download. Same idea, PUID, map time zones, and then I need to map its data folder inside to one that is within this repo right here. And that folder should exist when you clone the repo. And for the stable diffusion web UI, kind of same idea. We're going to build our image. That's the one that we just edited, which is in services/comfy. Going to name it ComfyUI, do the same thing. It doesn't require any CLI args. I picked that off of his other Docker container. I could probably remove it altogether, but he stated that this should be empty or undefined, so I'm going to do it too. And then we're mapping time zones, mapping local time. And then, again, we're mapping the container's data folder to a local data folder and the container's output folder to an output folder that's local here. And then a couple things for output, stop signal. So when it gets a sig kill, it knows how to stop. And then we're mapping our GPU, again, like we did earlier. But this one actually, instead of saying all capabilities, or does it say all? Oh, it says GPU. So instead of saying capabilities, we need compute and utility, and that's going to give us access to CUDA. So this is how you map to individual capabilities. I think if you say GPU, it does all. He limited it to utility and compute, so I'm going to do that too. But GPU, I think, will give it all. Restart and let's stop, same idea. Traffic network, same idea. And then traffic, same idea. And I just mapped it to stable diffusion .local.tektronic.us. So that's my internal DNS name. Remember, that's pointed to this Docker machine to get to traffic, to get to the UI. So because I'm running this in one stack, if I want to bring up this stack all as one, I can bring it up. Now I should be able to get to this UI, and there should be a default checkpoint, which is a model, and clips, which are text you can give it. So a default workflow or pipeline defined, and simply by queuing the prompt, it's going to load this default prompt right here. So it's loading the model, parsing or mapping the clips or the text to the model, doing some other thing with sampling, and here's our output, this image right here. If we wanted to make it bigger, let's say 1024, and then let's say this is 1024 also. We want to make it bigger, then we can run it again, queue prompt, and it doesn't need to load the model again, and it doesn't need to parse and map this text again. You could see it started right at the sampler and then did it again, which this is super weird. And so the two that come with it, you'll see more here, are two that are, I don't know, they're older versions of Stable Diffusion, and they're not that detailed. So how do we get better models? Well, we need to go out to Hugging Face. Out on Hugging Face, we should be able to do a Stable Diffusion 3 Medium. So this one was just released. This is Stable Diffusion 3 Medium. And that's the one I used in the video. I think it's actually pretty good. I haven't used a lot of Stable Diffusion stuff in general. I know there's a lot of controversy over their licensing, which I think they just recently made clarification. And some people complain that maybe the model isn't as good as previous. But really, this is the first time I use it, and I think it's pretty great, but I have no baseline. So anyways, to get this model, you actually do need to sign up to actually get it. And then they have licensing restrictions on using this commercially. Anyways, look at the license. I'm using this for personal stuff, but you will need to create an account so you can download these files. So I am signed in with my account now in dark mode. I don't know why they don't have dark mode on the public version. Just give me dark mode on the public. Anyways, so now I'm here and you'll see there are files and versions here. And so what we want to do is we want to download any of these models we want to use. They're pretty big. 4.3 gigs, 5 gigs, almost 6, 15, 10, and that's not a model. But you'll want to download all of these model files. We'll also want to download these text encoders, but I'll talk about that here in a second. But you'll want to download all of these files, and then you'll want to transfer them to your server, and then we'll want to put them in. Where do we want to put them in? I called it Stable Diffusion, Web UI Docker, into data, into models. If we go into here, we can see a couple of folders, and then we want to go into Stable Diffusion, and then we do an ls, and then we can see all of our models. These are the same models we just saw right there. So you want to transfer them all there. Another thing you'll need to do that I noticed, I was talking about the pull request a little bit earlier, they don't have this clip encoder folder created by default. So when you clone this, it's not there. So you'll need to create it yourself. Just make that directory. And then what goes inside of there? Well, let's go in here. I won't show you yet. But if we go back to Hugging Face, all of these text encoders right here need to be inside of that folder. So it looks like we have this clip G, clip S, and then these FP16 safe tensors. So we'll need to have these text encoders, which are also called clips. I'm figuring all this out. But I think that has the mapping for text already to the image, so it can take text prompts from different workflows. Anyways, if we look into here, we look into ls, you can see those same files. So I had to figure that out. I had no idea. And I will show you this because this doesn't follow the same convention as everywhere else. If you're wondering what the heck am I talking about, is that should be typically a clips folder on ComfyUI. But because this supports all UIs, or multiple UIs, I think in here, yes, in here, I had to figure this out too. Do you see this extra models path? So if we cat this out, I think what this developer is doing is pretty cool. It's kind of standardizing these folders so you can use any UI and then just put those files into the folders and any UI can figure it out. So here's the mapping then for ComfyUI. And I realized right here that, hey, it's saying that clip files are in model/clip encoder. That didn't exist, but I didn't know that text encoders and clips were the same thing until I created this folder and I was like, oh, that has encoder in the name. Maybe I put them there. A lot of guessing going on. It's kind of the Wild West right now. Things are getting better, but a lot of people doing a lot of things and it's moving really fast. So anyways, you'll need to create this folder and then you'll need to put those clips inside. There's one more thing you need to do. So there's also an example of how to use this. So they created some workflows right here, workflows. So here's 3 workflows we can load within ComfyUI to have more control over what we create. So if I go back to ComfyUI right here, this is a pretty basic standard workflow. Take some text, does some standard stuff, and it will output it. And I think I can actually do that with these clips now that I have it. But you'll see like, you know, although the images might be better, and I could probably give it a lot more text, you don't have as much control over it. Now it is loading that model, and it did parse the text now it's actually generating it, and we should see it out here over here. And I mean, that looks pretty good. So yeah, so it used a newer model. So that was using Stable Diffusion 3. But what I found is if you download these workflows and save them to your desktop, and then you can load them into the browser, and you'll see you have a much different workflow with some example text loaded here. So I'm going to move this over here just so we can kind of keep things compact and you can see everything that's going on. So the sampler, this should light up and this should light up. So if we see here, one thing you might have to change too, I think that this default checkpoint, this model doesn't exist. And so if you run it right now, you'll get lots of errors and you'll be like, what the heck? So what I'm going to do is set this to the Stable Diffusion medium safe tensors right here. And then the clips can all stay the same. This basically won't error out on your first try. So let's pass this text to encode to the model. Let's queue up this prompt. So it's loading this whole model. It's loading those clip encoders and parsing out the text, I think, and trying to map it to image stuff. Or that's what it's actually doing right here. Then it's actually generating the image. And that can take some time. I mean, you can see this is real time, how long it's going to take on a 3090 to do all this. And there we go. There's our image. So that looks good. So now that everything's loaded, let's just change this to say a male. I have no idea what this is going to do. A male character. So let's load this so we can see that, hey, everything is loaded. We just changed text. Let's queue up the prompt. It skipped all of this. So it's going right into generating this image right now. And it should generate this image. There we go. Didn't have to do much. But you can see it's actually changing it now. I could say short hair. Let's do short spiky hair. Spiked hair. Spiked is not a word. Thank you. Okay, short spiked hair, just to give it a little more variety. And we should see here in a second. There it goes. Okay, so that works. That's cool. So we have Stable Diffusion going, and you can do whatever you want now with this. You can play with it all you want. If you ever want to go back to the default, you can load the default, which will be just this generic prompt for you, and you can play around with it there. And again, if you want to load the workflows that we had, you'll have to load the one from your desktop. So one thing I should mention, because I can make this video as long as I want, is that sometimes models can get corrupted. I see this a lot on the internet. People will say, are your models corrupted? Are your models corrupted? And I thought maybe mine were corrupted because a lot of things weren't working. But you can check that pretty easily by getting the Checksum of that model, the Checksum, and then comparing it to that model. So I'll show you how to do it. It's pretty easy, and it's a good way to figure out if your file matches exactly what you downloaded. So let's go back to where our models are. So it was here, and then it was data, and then it was models. And let me just go into Stable Diffusion, and then let me clear and do an ls. So let's say we want to check this model right here, just the SD3 medium safe tensors. So we're going to do a shot of the file, 256. To see the output, I'm going to say this one. This is going to, I don't want to say tax the CPU. It's going to tax one core. It's single threaded. If we go back in, and this is not a big deal, but this was just me being super curious while I was running before. But if we do a top, we're going to see that the Checksum is running. It's going to peg one of the CPUs. Not a big deal, but it's crushing through that as fast as it can. And we should get a value when it's done. There we go. So a value right here. What I typically do is I copy this to my clipboard. Then let's go back to Hugging Face. And then let's go to that file right here. If we click on it, it shows the Checksum. And what I do is just do a control find and boom, there. So this matches exactly. It's probably a good idea to go through all your files and check to make sure that they match this Checksum. Spend an extra 5 minutes now will probably save you, I don't know, an hour or so of pulling your hair out later if it doesn't work. Cool, that's that. Now that we have Stable Diffusion up, we also configured open-webui to be able to generate images for us. So let's check that out. So let's go back to open-webui. And the way that this works is, I don't know, kind of clunky. I don't know if this is how it works on ChatGPT, never tried it. But the way that you do it is you basically tell it to repeat a prompt back to you. You can actually have it generate a prompt for you, but let's tell it to repeat something back to us. So we're going to say repeat, and you can do this any way you want. You don't have to put repeat, right? It's a language processor. So you could tell it, hey, repeat this back, whatever you want, it will figure it out. But I'll say repeat back, a dog flying with a spacesuit on in outer space with Saturn in the background. Comic style, vibrant. I see people put this a lot. I think it kind of helps the model to know, hey, use or generate a super high quality image. I don't know what else to put. This is good enough. So hey, repeat back to me. And then what you do is click on this generate image icon. This looks a little bit weird because I'm zoomed in, but it should be an image. We click generate image. And if we go take a peek really quick while this is running, we can probably see it running on BTOP. So let's close this. So it's generating now. Hey, there we go. So we said a dog flying with a spacesuit on in outer space with Saturn in the background, comic book style, vibrant 8K. Hey, it did pretty good, except for I can't tell. Yeah, he's got an arm in the wrong place, but hey, that's kind of par for the course. We weren't being specific enough. But anyways, pretty good, works pretty good. And I love how it has this watermark down here of some image they scraped on the web that had a watermark. And so it, it knows enough about watermarks that it generated a watermark. That is pretty awesome. Pretty sad, but pretty awesome. Cool, so that works. If you want to tweak that a little bit, let's go back into our settings. Let's go into global settings, and then let's go into images. And so here we can change the model that we want. I usually use, I think this one, I think we have to use clips for this. And you can change the steps, amount of steps you want. 40 is usually pretty good, pretty high. What I usually do is 28 because it goes a little bit faster. And so you could generate something else. If we want to repeat that same thing back, let's just grab my text. I know I could regenerate it, but I kind of want to do it in a new text just so it doesn't get all wild. Repeat. There we go. Let's generate an image for that. Going to take a peek at BTOP again. Using a lot of GPU. Boom. Should be done. Hey, there we go. And this one has an extra tail. Oh, I like this one better. Outside of the extra tail, I think that's pretty good. That's pretty good. So anyway, super fun to play with. It's nice to have it in chat if you just want to do something really quick. But if you want to do something more detailed, you should probably hop into ComfyUI and do it there. Okay, now you can see why I didn't do this video on my main channel because there's a lot going on. So next up is Whisper. And so this is the Whisper stack. As you saw in the video, it was a self-hosted version of Whisper in a web UI that could parse or transcribe audio into text from either videos you upload or from YouTube videos. So here it is right here. So it does depend on a few things. So Mongo, it's going to spin up a database just for this stack. And then we're going to pull some stuff from an EMV. Again, here's my EMV. I'll put this in documentation too. Username and a random password doesn't really matter because this is internal and no one can get to it. That's not the greatest password, but hey, it's internal and it's for testing only. But it's going to create this. We're going to do, again, mapping time zone, local time, our database storage. So where's that going to be stored? It's going to be there. Where our log's going to be stored? There. Environment variables. And then this is passing in the root username and password. And it will just default to Whisper if I didn't supply one. So that's a little bit better than Whisper. Kind of like Whisper. No one would guess it. So it'll pass that in, whatever. And then, it's starting up MongoDB. It's also going to spin up the translation service. I'll be perfectly honest with you. This doesn't seem to work right. I'll show you here in a little bit. Or maybe not show you because it doesn't work right for some reason, like the videos get hung, they never finish. So unfortunately, I haven't figured out the translate piece, but maybe by the time you see this, it will. I'm sure it's just something super simple. So this is the Web Whisper from Pluja, and it's using the GPU version of it, EMV file, mapping volumes, logs, all the typical stuff. And then I'm exposing this right here. So it's internally on my own DNS, whisper.local.tektronic.us. And remember that points to this Docker machine and then gets routed through traffic to the service. And then here I said, hey, it depends on translate, depends on Mongo before it starts up, some additional environment variables, and then telling it to use the GPU. So let me go back to my stack root right here, way down in there. Then I'm going to recreate the stack. It's actually running right now. I don't need to do it, but I'm showing that just in case you don't combine your stack like me. Then if we go to the URL, here it is. So we can say new transcription. Then I can choose a file. This was actually that Bruce Lee home video. I'm going to say medium model, auto language, and GPU. And so if you don't have the model, it'll actually download it for you. So I tend to go medium most of the time if it's scripted. If it's a meeting or spoken word or a conversation, I go a little bit smaller because it will take out stutters and filling words, like a lot of ums and it'll stutters and filler words. What I was just doing, it will take that out of the transcription. But because this is me as a kid pretending to be Bruce Lee, that won't matter. So anyways, I'm going to start it. So this might take some time. I think it has to process the audio, has to map it all out. We can see the CPU is busy. Now the GPU is busy. So it's actually, I think, transcribing it. Looks like it's done. Let's go back. Here it is, 386 words. Oh, I'm scared to look. And here it is. Actually, yeah, so sound effects. This is actually pretty funny. Yeah, so, oh gosh, I can't watch. This is, yeah, so anyways, not the greatest. Here are the few lines. I thought you were dead. As you can see, I'm very much alive, and me and my big face. So anyways, this transcribed it. It works fine. It works just fine. So anyways, we'll move on to something else. So anyways, what I was saying earlier, if we try to translate this, I'll do it so you can see. I think it just hangs forever and it never really finishes. So I'll have to look at the logs and see what's going on. Hopefully I'll fix this by the time you see it. But I honestly think it has something to do with the code itself and not something I can fix on my own. Anyways, we'll let that go and we'll move on. Next up was Home Assistant, and I'm not going to show you how to set up Home Assistant itself. You should have that running already. What I am going to show you is how to create containers that Home Assistant can use for both Piper and for Whisper. I'll show you that here in a second. So Home Assistant can use this thing called the Wyoming protocol. And so that's a protocol that Home Assistant can use to communicate with both Piper and Whisper. And so you have to get this installed first, the Wyoming protocol. It's an add-on. You can install it. And then you need to do some configuration. It does show how to manually configure this and add the integration if you want, if clicking this button won't work. But anyways, you need to get this integration first. So after that, if you're running Home Assistant in a container like I am, then we have to add these containers for Whisper and Piper. So here's my Home Assistant stack. You can see, looks pretty typical. You can actually see that I depend on faster Whisper GPU, so that's going to be Whisper. And then I also depend on Whisper Piper. This is the default one, but I found there's actually one that can use the GPU now, which is lightning fast. So not going to go over too much of Home Assistant, but now what I am going to show in my stack is now I have this faster Whisper GPU service. This is actually pulling from Linux Server IO, so they build a container that does exactly this. It uses the GPU, connects to the same network that all of these are on. You could specify your model. You can specify Beam, which I think is for parallel processing. And I think trying to parse the text, I'm just setting it to 1, set the default language to English, some configuration, and then map the GPU. So that will be Whisper. And then Piper is piping text to speech. So for this one, I'm using this Wyoming Piper. I couldn't find a GPU-enabled version. Honestly, I didn't look at Linux Server IO. I hope they have one, but I hope I wasn't oblivious to the fact that they might have one too. Anyways, I'm not going to act like I checked, but Wyoming Piper is the image you'll use. You could use one with the GPU if you could find it. And then we're just mapping data, setting some stuff up. There is a command line you need to run to pass to this when it starts up. This was all copied from their documentation. And then here's the GPU I'm passing in, even though I'm not using it. I did that to see if I could swap some stuff around with images earlier. So technically, you don't need that. Doesn't hurt to have it. So that's all you need to do. And then once you recreate your Home Assistant stack and go into Home Assistant, you'll go into your settings. And first, you'll want to go into Devices and Services. And you'll want to go into Wyoming protocol. And here you probably won't see any services configured. You'll need to add your own service. And so the way that I've done this, again, like all of my other stuff, I'm doing this using internal Docker names and internal Docker networking. So I'm not using ports or localhost or IPs or anything like that. So what I did here was I put in faster whisper GPU. And then I put in the port, which we could find right here, 10300, and then I submitted. And now I just added 2 and I don't know which one it is. So anyways, gonna assume it's this one. I don't think it matters. But you'll do the same thing for Piper then too. And so how did I do that? So Wyoming Piper, and I think the port is 10200. So I'll just add it again, add service, Wyoming Piper, and the port is 10200. Submit, and it's success. So now I have 2 Pipers, let me delete it. So anyways, if you want to use IPs and ports, you totally can, but I like using the internal Docker service name and keeping everything internal and only exposing what I need. So anyways, now after that, what you'll need to do is go into settings, and now you'll need to go into your assistant. Where's my assistant? Voice assistant. You'll need to add an assistant. I've already created one. I've called it Mr. Roboto. You'll name it. Then you'll set the speech to text, so faster whisper. You'll see it listed here. Same with Piper. You'll see Piper along with some other things. You could choose the voice you want in the output. They're all really weird, so I just chose Amy, medium. And then if you set a wake word, you could set that there. We will do one more thing before we do that. So we didn't add the Ollama integration. So let's go into settings. Then let's go into devices and services. You'll want to add Ollama. And then we'll need to configure an entry, I think, per model. So again, I would add HTTP Ollama. And I think the port is 11434. I just had to look it up. And why am I doing this? Well, again, I'm using Docker networking, keeping it internal, and that's the internal name. So I'd say next, there it is. And then we could choose a model. So if I have those 2 models, I could choose another model. If I wanted it to talk my ear off with Phi3, I could. I'm not going to choose any other one. I'm just going to keep those right there. But you can see which ones I have downloaded already, which is super duper nice. I will add Phi3 because, then it's there if I need to use it. And then you can manage them then this way too. Remember, that's not going to delete the model. That's just going to delete the connection or the definition of this connection. So then after you added Ollama, you could go back into the voice assistant, you could edit your voice assistant, and then you can choose the agent that you wanted to use with the model you wanted to use. So I'm going to use the 8B. The nice thing about using Ollama essentially, so one instance and the same model for all, is that they can all use the same model. You don't have to swap them in and out, and you get a lot better performance that way, rather than having multiple versions of Ollama or multiple versions of a model for different applications. If you use the same across the board, especially for chat type stuff, you'll be in pretty good shape. Okay, so how do we use this now? Well, you actually go into somewhere from your dashboard, click here, and again, that demo I showed where it was like, if we just went to the Home Assistant one and said, how many lights are on in my house? It has no idea what it's talking about, but if we switch to Mr. Roboto, he's pretty smart. How many lights are on in my house? And he's telling me, hey, my Elgato lights are on, and there's a plug on in the bathroom, which he's exactly right. But I will ask something else, just so you can see, now that the model's loaded, it'll run a little bit faster. So what are the temps inside? There it goes. So it just listed them off. Cool. So that's working. It's actually pretty cool. The other thing you could do is voice to text. So let's see if this is going to use the GPU and it's going to work. What time is it today? That was super fast. 24, so yes, it's working, and it was super fast. It processed my voice really fast with the GPU version. That was scary fast. And then it responded scary fast too. Let's ask it one more thing. How many lights are in the upstairs bedroom compared to the downstairs?
According to the climate devices, asterisk heat upstairs, off asterisk AC upstairs, cool.
Okay, let's ask it one more thing. I think it got cut off. How many lights are in the upstairs bedroom? It's not the greatest.
The following lights in
I'm here to light some of the upstairs bedroom. No. How many lights do I have in my house? There we go.
According to
how many devices are in Home Assistant? That's funny. The voice to text parsing didn't pick it up right, but then the natural language model answered the question I was asking anyway. So how many lights do I have in my house in total? So pretty cool. That's working. Awesome. Glad I got the GPU piece working. Now code completion. This is super duper helpful if you're ever writing some code, or not even code necessarily, if you're writing JSON or writing any kind of language. it can help you out and make suggestions as you type, making it much quicker to complete tasks. It'll also give you a chat assistant directly within VSCode. Super simple to set up. Let me show you. Before we do that, I want to point out again that I have basic authentication turned on Ollama, and I do that through Traefik. Really quick, if we go back to Ollama, you could see here I'm using this middleware called auth, and then I'm using this basic auth middleware, which is reading this environment variable, which is then reading this hashed username and password. So again, I do that so anyone coming through Traefik, so really external Traefik, has to supply basic credentials in order to use it. Anything internal doesn't need to do it. Now, if you don't want to do that, so just comment out this, this, and this. So comment out anything with auth and you're good to go. If you do want to do it, you just need to hash a password like this and enter a password twice and it will echo it back out. And I'll have that in the documentation as well. So once you have that up and running, you'll need to install the extension called Continue, and we'll need to configure this. So let's go into extension settings. If you want tab completion, basically what we're going after, you want to make sure that you have this enabled right here. So once that is configured, we actually need to configure something in the config.json. I usually open the power menu, and I think it's Command Shift or Control Shift, whatever you're using. P, open this menu, and I usually type in continue, and you want to open config.json. So once you get into here, here's where you configure your models. You might have some configured already. I would just clear it out. But what I did was create one called Ollama self-hosted. The provider's Ollama. Models are auto-detect, so we can pick any one we want. Then the API base. So where are we going to go to get to this endpoint? And like I said, mine's going to an internal Ollama local.tektronic.us. It's over HTTPS because I'm serving it through Traefik. And here's what I figured out. If you want to pass basic auth, you need to add this request options, headers, authorization, basic, and then a hashed version of your username and password. So basically what you want to do is your username, password, and you need to hash that. And I'll have a command example in the documentation. So once you have that, then this will give you Ollama to chat with within VSCode. If you want to then set your auto tab completion, you can do it here. So I set the title to StarCoder 3B. This can be anything you want it to. The provider again is Ollama. So I'm saying, hey, use the model StarCoder 2, the 3B version of this. And then again, I'm pointing it at my endpoint. And again, I'm adding these basic auth headers. And then you can disable telemetry if you want. I did. Then you should be able to get to your chat client. I think by default, it's over here on the left. I've moved it over here because it's a little bit easier because I usually have my folder view over here, but I've enabled it over here and now I can get to my chat client. And you can see I can toggle between models if I want. Now, when you chat to this assistant, the Llama model will work just fine, but since this is a code-based kind of chat, you want it to be more aware of code. Choose something like CodeGemma 7B and load that model and then ask it questions. You can give it context for your code with different commands, or you can just ask it any kind of question you want right here in this menu, like example anchors in YAML. And again, if you haven't loaded this model before, which I haven't loaded that model, it'll take a second, but here you can see now it just gave me examples of anchors. And I don't think that's right. Maybe they aren't called anchors. This is not what I was going for. I was going for YAML anchors. I don't know. Maybe I have the wrong model. Maybe I'm asking it the wrong thing. Maybe I'm calling it something different. So like YAML templates, YAML templating? No clue. So let me try a different model real quick. This just seems weird. Like it wouldn't know that. YAML anchors? Didn't spell it right. But Llama should be able to figure it out. Figures out all my typos. Yeah, so Llama got it pretty good. Yeah, so these are the anchors. Anyways, maybe I was using the wrong model. Maybe I was using one that was geared towards type ahead and not geared towards code or natural language. This is what I was looking for, and that's how it works right there. Cool. So you could have it on the sidebar, but like I was saying, you could also have it built in. So we should start to get some tab completion here. Although it doesn't make a ton of sense to get tab completion, there it is. That's actually already there. YAML is a little bit different. I want to see if it's smart enough to know, like I don't have container names on all of these. Container name there, container name there. I want to see if it's smart enough to know if I do this. Look at that. Oh, yeah. Oh, so it is. Oh, yes. That's actually good. This first one is container name. It's exactly what I wanted. Networking depends on is empty and undefined. So it did it right. Yeah, you usually just leave these off if they're undefined, but hey, that actually works really good right there. I think I forgot one here too. And so let's see, actually I don't want it there. Let's do it after build. And that was actually, oh, you could actually fix it for me too. But here is where I wanted exactly that container name. Awesome. So as you can see, we're getting code suggestions too. All right, so that's my self-hosted AI stack. It's all running in Docker. It's all running great. It's highly integrated, and it's all working on one of my servers here in my home lab. If you have any questions, post them in the comments below. I'm Tim. Thanks for watching.